Anil sir, they are joining or?
No, sir. We are waiting for the chairman team.
Okay. No problem, sir. We'll wait.
అంటే వాళ్ళకి లాగిన్స్ వెళ్ళలేదు. More than 1,000.
Good afternoon, Subhakar garu.
Sir, good afternoon, sir. Madhumurthy sir, good afternoon.
Good afternoon to you all.
Yes, sir.
Good afternoon, Nivedita ji. And
Nivedita madam is online.
Alka.
Yes.
Hello,
Yeah.
sir.
Namaskar. And I welcome all the participants for the second module of the FDP on quantum technologies, quantum computing. I have with me
Sir.
the entire team of AppSheet. We are strengthened. I have Professor Vijay Bhaskar Rao garu, who is the vice chairman, who joined recently yesterday, and also Professor Madam Ratna Sheila Mani, vice chairperson.
Namaste.
And we also have Professor Tirupati Rao, who is the secretary of the State Council. Welcome to all the participants. After the first module, congratulations to Professor Subhakar. The module went on so well. When I've been to a recent program, Subhakarji, there were requests coming from the industry participants who wanted to join this particular program. And people, the word has spread, the message has spread all across about the success of the program, about the expertise, and the lectures that were held with participation from IIT Madras, CDAC, and all the experts from industry like IBM, TCS, okay, and the participation of NQM. They were happy. The feedback we had was also extremely nice. And I understand that there are quite, the response for the second module is equally good. How many did they register?
Sir, as of now,
What's the
we have, sir, as of now, we have paid participants of 500 and above. And we have, from AppShe, we have received about 600 invitations, approval for 600 faculty members, which we have already sent. We have also invited the earlier about 1180 people who are there who have registered for course one. We have
Yes.
invited them also. But as of now, those who have registered are 500, and those who have joined the program are about 370 as of now. 375
Wonderful.
as of now.
Wonderful.
So there
Wonderful.
may
I
be
think,
574 have paid registrations. So that is the good number, sir. And we have opened the time till Sunday. So till Sunday, we will open the registration. So maybe another, I'm hoping this time we should touch around 800 to 900 or maybe thousands. Actually, there are some issues of today's joining because of that. So we have put the YouTube link. Tomorrow, we will sort out these issues. Actually, new participants have joined and they are not used to the WebEx module and all. So it takes time because we collect the attendance from WebEx itself. So there is a process to register, then they'll get the link, then they will have to join. There is a registration ID, unique registration ID for everybody to maintain the attendance. So that process is a little cumbersome. So hopefully we'll sort out by tomorrow. We have shared the YouTube link with all participants. They will be able to watch either on WebEx. If they are not able to join WebEx, they will watch on YouTube for today.
oh, great. But
Yes.
about the first module that we have done,
Right,
there
sir.
are also participants who have been saying that they have not received the certificates.
Yes, sir. Yes, sir. Some of them who we have released 480 certificates, sir. Some of them do not
Yes, sir.
have sufficient attendance. So we have stopped around 108 certificates we have withheld. So they will have to watch videos because they have not attended any classes. So we said that unless and until you watch some 10 lectures, we will not give the certificate. So they are now watching. They have got good grades actually. They have studied, they have prepared well, they wrote the exam. But because they have not attended, we just restricted for some time. Otherwise, sir, many times people will pay the money, just write the exams and wait the certificate. So they have to attend the classes because a lot of valuable content is coming. So at least they must attend some 70% of the lectures. That's our expectations.
Good
So
mechanism.
I think you agree with me, sir. I think you agree with me.
Yes.
We have that 70%
very much.
attendance criteria. So we will relax that also. At least 50% they must complete. That's what we are looking at. So once they do that, 10 videos they have to watch on WebEx. Once they do that, we will issue the certificates.
I appreciate the process because
Yes.
most of them are working professionals. They are all teachers. They have their own workload despite the institutions permitting them to
Right.
participate in this program.
Yes.
Well,
Sir, actually, I was very happy because you have requested the institutions to give them on duty. So during that
Yes.
period, they don't have any other administrative or any other official work. So they have to attend. So that is what is slightly I wanted to restrict. Otherwise, we will release the certificates. Next Saturday, definitely we will release all the certificates. Thank you, sir.
I think what you did was right because
Right.
they have been extended the facility of on-duty process during this
Right.
course to attend.
Right.
I think that's the thing to do. And I think the material is still available on the web, right?
Yes,
For
sir.
them to
Material is
download
available on Canvas learning management system. They are all registering on Canvas. They have the materials.
I wish the program continues well. There was another query that came from the industry. I was mentioning that AICT is considering to award a certificate for people who have attended minimum of 6 modules here. If somebody missed the first module, introductory fundamental module, can they do this? Is another
Sir,
question.
actually, they can do any 6 modules. Actually, 18 credits. Totally, AppShe has decided to conduct 10 modules.
Yes.
2 modules we have covered combined together. 0001, 0304 we are combining. So totally we'll conduct 10 modules, sir. In the 10 modules, they have to attend any 6 modules. Any 6 modules is sufficient, right? And the QT 0001, we'll try to put it as a MOOC course, sir, where they can do that. They will get the same certificate. We'll consider, sir. As of now, I will request your good officers to put a word with Professor Sitaram also, because
I will.
he is wanting to ensure that in the next 1 month, he will announce from AICT side that all those who do these AICT courses, not only in quantum, but in AI and in blockchain and IoT and cyber security, PG certificates will be issued for all faculty members who do these courses online and have a 1 week or something offline interaction. So the PG certificate program is already available online. Many of the IITs, NITs are offering that. So he was very happy when we approached him. Last week we visited Professor Sahula sir and myself, and we could interact with them. And we have had very good response from him. And maybe next 1
Yes.
month we'll announce the details, sir. Then all our participants, any 6 courses out of that will be 3 credits each, totally 18 credits once they complete. There'll be one written exam and a face-to-face interaction for a week's time, I think. And accordingly, we'll award the certificates. So I extended that,
Yeah.
we requested that to extend to AppShare programs. He was very much happy. He said, yes, we'll do that.
Wonderful. Yeah.
Yes.
The purpose of me raising this issue at this point is to make our
Right.
participants aware that
Right.
there is a possibility of getting a certificate for doing this, not
Yes, sir.
just the modules that they complete, but an overall certificate. They would be the first batch who would be graduating in quantum technologies. Right?
Right. Right, sir. It's a
Yeah,
PG
that-
certificate applicable only for faculty members. They can use that in CAS or in also the interviews. They will get an edge, definitely. Sure.
That's- That's it. I
Uh,
wish you good luck and
Yes,
all
sir.
the
Thank you. Thank you so much.
participants.
Yes.
Wonderful
We'll-
learning
Yes, sir. Yes.
all through. Thank you so much. Please go ahead.
Yeah, yes, sir. I just want to formally start the program, and at the beginning itself, I would like to, of course, you have shared informally, but a formal process. Maybe I will request Professor Madhumurthy Garu to share a few thoughts about the course and also the importance of quantum computing to start with. Then I will request the Vice Chairman, sir, and Secretary, ma'am, also to share a few words. I'll request Professor Madhumurthy, sir, for the participants' sake. I just want to introduce, sir. Sir is professor of the higher administrative grade, HIG professor in National Institute of Technology, Warangal. Presently, he is the chairperson of the Andhra Pradesh State Council for Higher Education. And he has been entrusted this responsibility by the Chief Minister of Andhra Pradesh to ensure that the Andhra Pradesh state moves ahead in enhancing the quantum technologies. And hence, he has taken many initiatives. One of the successful initiatives, the hackathon, the quantum hackathon, which was conducted across so many colleges, and they have now reached the semi-finals level, and a lot of learning, especially for the students. So while this was going on, sir also requested that can we have training faculty development programs on quantum for faculty. So that is where IBM and National Quantum Mission approached MNIT Jaipur, because we had already doing a series of programs based on AICT curriculum. So we started this program, and I met sir and we had a good meeting. I was also invited to be on a committee for quantum computing. So I thank Professor Madhumurthy sir for this initiative. If it is for this series in AP State Council for Higher Education, the series on quantum, it is Professor Madhumurthy sir who is the one-man initiative, I can say. Of course, Professor Dr. J.B.V. Reddy, Dr. L. Venkat Subramaniam from IBM, they have all joined hands. Mr. C.V. Sridhar from TCS, they all encouraged. But it was a vision of Professor Madhumurthy Garu. So I would request him to say a few words. Thank you, sir.
Thank you, Professor Subhankar. And I think we did have a wonderful beginning with the Chief Minister of Andhra Pradesh coming out with a Quantum Valley Declaration. The initiative from the state government identifying the future opportunity at the right time and trying to put our nation amongst those selected 6 or 7 which are already operating on quantum technologies. Of these, the National Quantum Mission, which has been launched in 2024 with Dr. J.B.V. Reddy heading the National Quantum Mission Cell, being so dynamic and active, had been so great support for all the activities that the State Council has been taking on. The question that we had was about the scarcity of manpower, trained faculty for educating our students on the quantum technologies and the forthcoming opportunities that would put us at a next level. Immediately, there was great help and guidance coming forth from people like Dr. C.V. Sridhar, Dr. Venkat Subramaniam C.V. Sridhar from TCS, and Venkat Subramaniam from IBM, and the great support of Dr. J.B. Viridi, who had also taken me around to CDAC to have a physical inspection of the laboratory facilities before we all could submit, all our universities could submit our proposals under the algorithms as well as the UG teaching labs. With the support of Subhakar, Arjit Sharma, we all conceived to have a program of this nature to immediately meet the requirement of trained faculty to handle courses on quantum technologies. In fact, Andhra Pradesh State has taken a lead in introducing quantum technologies, the curriculum developed by DST and ACT, not only for engineering, but also for all the degree programs. Now, quantum technologies is also made a minor subject for the degree programs. And this was with the initiative and help that was supported by people like Subhakar, Arjit Sharma from IIT Tirupati, of course, Venkat Subramaniam, C.V. Sridhar, J.B. Reddy, and we also have Anil Prabhakar Garu also helping us in this. Sadanand from CDAC was also of great help to provide on hands-on training for physical laboratories. There seems to be a great demand. We had a question on my mind of who would be the takers and what would be the future of quantum technologies. When we have initiated the hackathon on quantum technologies, the response was immaculate. In fact, it was to our surprise that we have about close to 3,800 teams participating in hackathon so far. And the response had been overwhelming. All the organizations, all the institutions were also so thrilled seeing the enthusiasm put forth by the students, coming up with their own ideas on the 10 problem statements that we have developed for the hackathon. And very soon, we are likely to have the finals. And with this sort of a response, the registration of students for quantum technologies as a minor has also doubled. In that sense, I think the purpose of conducting the hackathon has shown us several other directions that were never presumed to help us in the academic front. With this, I now take the opportunity of seeing a great future for Andhra Pradesh and for those who have been acquainting themselves with the quantum computing and quantum technologies. All of you who are faculty members as well as from industry, I think should lead us into the next growing area of quantum. In fact, in the coming January, Amravati is going to have a quantum computer installed. There are many who are going to come up to establish. I believe there is also one more, QPI, also coming to establish a quantum computer here. With this, there should also be users as well as use cases. We expect that most of you would come up with use cases in each of your disciplines that you belong to. The response from life sciences areas like life sciences, commerce, pharmacy, and no, other than engineering, had also been extremely good. We thank each one of you and your institutions who have sponsored you for this particular program. Thank you so much. And Professor Subhakar Garu, I thank all the organizations that have been supporting us, particularly MIT and NQM behind us, and your own MNIT Jaipur. Thank you. Please convey my respects to the director Padi, Professor Padi, and Salanki as well. Thank you so much and wish you all the best. Thank you.
Thank you so much, sir. Thank you. Participants, that was Professor Madhumurthy Garu, who is the chairman of Andhra Pradesh State Council for Higher Education. Because of him, we started the second cycle for those who just joined. Let us now listen from Vice Chairman of the Andhra Pradesh State Council for Higher Education, Professor S. Vijay Bhaskar Rao. Sir is a professor in physics from Sri Venkateswara University, Tirupati. He was research and R&D director also, and he was acted as the vice chancellor of Vikram Simhapuri University. So presently he serves as the vice chairman of Andhra Pradesh State Council for Higher Education. And because sir is from physics background, he is very much aware of what's the actual challenges in quantum. So I'll request sir to say a few words. Sir, vice chairman, sir. Yes. Sir, sir, you are on mute. Sir, you are on mute. Sir. Unmute, unmute. Ratnashila Madam, Secretary. Ratnashila भी Vice Chairman. Sir, please go ahead. Sir, okay. Anil sir. Audio is clear. System पे कर लीजिए.
ఫోన్లో అని చెప్పేసేయండి. సార్ వచ్చింది కదా.
No, sir, we are not able to hear. Okay, Anil sir, we will wait till you connect to that. Participant, please be patient. I think there is some issue there. So once it is over, then Nivedita ma'am is waiting to start. Sir, yeah, you are not audible, sir, as yet.
Sir, laptop lo connect time, sir.
Yes, sir, we are able to listen now.
Yeah, please.
Yeah, I'll request Vice Chairperson, sir.
Yes, sir. Yes, sir.
Sir, Professor Vijay Bhaskar Rao garu, please share. Yeah.
Good afternoon to
Yeah.
all of you.
Yes, sir.
It's a great pleasure to join with APSI. And as our chairman pointed out rightly, because there are a lot of developments going on in the quantum computing, all of you know, and then we have a national quantum mission is also there. And also our NEP also has made some mandate about quantum computing and other things. And Andhra Pradesh also has taken up an initiative of developing quantum computer also. So based on all these requirements, today the APSI and jointly is organizing a program, FDP program on quantum computing. I think most of you are aware that this quantum technology is going to revolution in all the sectors, especially in computing, communications, as well as sensors and other things. So a lot of research is going on abroad and other places where the free space optical communication is coming up, and all your computation facilities will be going to be change, and all our sensor technologies will also going to change. So we need to train manpower to teach as well as to conduct some research. This National Quantum Mission also has invited some proposals, and several universities also submitted to the National Quantum Mission under this quantum technologies. So there is a great demand and need to cope up with the recent technologies and developments in quantum, these things, initiatives. We need manpower. So to teach as well as to do wonderful research and make use of all these important initiatives by the government of India as well as the government of Andhra Pradesh, especially for modules what they have designed for quantum technologies is very much required for the lecturers as well as faculty members working in different degree colleges as well as in the universities. because they had to come and learn the things and go and teach the students about these quantum technologies. So in this connection, I really appreciate efforts put on. I understand the first phase of the FDP program. Participants they all completed this training. Today we are going to get about 700 or 800 participants. So this is a very good initiative, and we should all look forward to fruitful discussions and training, and we need manpower. So with this manpower, we are going to meet future demands and technologies that are going to revolutionize all our research and as well as teaching platforms. So I appreciate for all the efforts, and I thank all the people, especially our chairman sir, for taking up a wonderful initiative of organizing this FDP program. I request all the participants to listen to the eminent speakers who are going to take classes and take the most of the benefit. Teach or do research. Yeah, I wish all the best to the participants here. Thank you one and all for giving me this.
Thank you so much, sir, for your valuable time and also your guidance. And we are hoping that you are recently you joined APSHE, and I hope that APSHE will grow to new heights under your this thing. Next, we have Professor Ratna Sheela ma'am, Ratna Sheela Mani. She is a professor of Acharya Nagarjuna University, Guntur. Ma'am, I was a student of Acharya Nagarjuna University. I studied in SVH College of Engineering, Machilipatnam.
Okay.
Very happy to meet you. Ma'am was also the rector in charge at Acharya Nagarjuna University. She was principal of the ANU College of Arts and Commerce as well. Presently, she serves as vice chairman of AP State Council for Higher Education. Ma'am's academic discipline is English. Yeah, as in this quantum program, we welcome ma'am as vice chairperson of AP State Council for Higher Education. Ma'am, I request you to share a few words of greetings.
Yeah, good evening, all of you. And I'm happy to be part of this second module of this faculty development. Well, I can't say I can speak with much authority or knowledge about the subject, but we've been hearing back in the university also about the quantum mission and quantum computing and all that. In the universities also, particularly in our university also, we've undertaken a few measures to make it part of the curriculum and all that. So since this is going to be the new science or technology, what the earlier speaker, the chairman and the vice chairman also have suggested, I think we need to train more people in this new subject so that we can rise, up to whatever developments are taking place. And unless the faculty are trained, they wouldn't be able to impart all that knowledge to the students. And the chairman sir was also talking about the hackathon. We had a lot of interest and participation in that back in our university also. So I think there is a lot of interest among the young people, and naturally young talent is necessary for this new area, new subject. But for that, of course, they also need to be trained by competent people. So I hope this second module, and I think in the afternoons you have it every day for 20 days. I was just hearing how the participation is good, and I hope more and more people are motivated to join in these programs and get the skill, the knowledge, and the empowerment also, so that they can transfer the skills to the students. So I wish the program every success. Thank you.
Thank you so much, ma'am. And At this time, I will request Professor B. Tirupati Rao, sir, who is the Secretary of AP State Council for Higher Education. He is also a senior academician, and he is from the Department of English and Communications at Dravidian University, Kuppam, Andhra Pradesh. He holds degrees in MA, PhD, and doctorate in literature, DLit in English, with specialization in literacy and cultural studies. Professor of English and Communication at Dravidian University. Presently, he has served as co-convener of UGC and APSHE sponsored international seminars, especially the one on teaching literatures in English for cross-cultural communication. And he has written many books, and presently he serves as the Secretary of the AP State Council for Higher Education. I request Professor B. Tirupati Rao, sir, to share a few words of greetings.
Thank you, sir. Good afternoon to one and all. I appreciate this initiative. We are witnessing a series of new programs or new kind of technologies that are coming onto the scene. And we know that we should equip ourselves with these kind of technologies. Otherwise, it would be very difficult to move along the stream. So this is a kind of initiative taken by APSHE and others, organizing an event like this, FDP like this, to equip the staff and students with the new technologies. And I appreciate the people involved, and the response seems very overwhelming. Nowadays, participation around 1100 is not a small number. So I appreciate the organizers and congratulate the participants. Thank you very much.
Thank you, sir. Maybe if Professor Anil sir wants to join, maybe the camera will be shifted. So let me give a brief overview of the course. The course Quantum Technologies, the Foundations course that we are looking at, QT02. Here, basically, we are going to dwell more on quantum mechanics. So a lot of lectures will be on quantum mechanics and a little bit of information on quantum, that is solid state physics, which is also necessary. A little bit of orientation on digital communication will be introduced. And also you will also be learning about complexity classes, P and NP problems, some of them. So it's a combination of physics, combination of computer science and electronics, the foundations which are needed for quantum technologies. So this course is called Foundations of Quantum Technologies, FQT. So we will take this course. This is equivalent to the QT02 course, which is there in AICT curriculum. And faculty will be, most of you know, but we will have new faculty, Dr. Ritajit Majumdar. He will be joining from IBM, and Dr. Anindita Banerjee, she'll be joining from CDAC Pune. Apart from Dr. Ashwath Babu, Ms. Nivedita De, and there will be one Ms. Janani from IBM as well. So these will be the faculty members who will lead you through this course. And the course is already conducted in MNIT Jaipur. If some of you want to listen to those lectures also, similar speakers were there at that time also. And we will listen to those lectures and we can take it forward. If you want, you can watch the lectures on YouTube also. And here we will share the things. So for those who have just joined, for those who do not know about the more details about the course, let me briefly tell you. We will actually start with the lectures on WebEx. The attendance will be directly marked. So you don't have to worry about the attendance. Attendance will be directly marked on WebEx. The material, the slides that the faculty members share, and the video recording of the lecture will be available on the WebEx login. Right? So you'll have to go to Canvas. We will share the Canvas login shortly. So on Canvas, all the course material, the videos, the lectures, and the lecture slides, and the quizzes that will be conducted will also be on Canvas. So hopefully tomorrow all of you will have the Canvas logins and you can check that. We will give you another PDF in the WhatsApp group and we will explain how you can do that, right? We will open the WhatsApp group again, so don't worry. At 5:30 we can take it forward and you can listen to the lectures again, right? So hopefully we have, I think if they join maybe towards the end, the AP State Council for Higher Education will share their thoughts. I think if some of the participants have raised their hands, please post them as comments. I will address them in the chat. Meanwhile, Ms. Nivedita Dey is waiting for us. So I'll request. I'll request Dr. Arka Prakash Majumdar, who is the coordinator also along with me for this course. Last course, you had Dr. Mahipal Jadeja with us. This time, Dr. Arka Prakash Majumdar will be the coordinator. He is assistant professor in Department of Computer Science and Engineering, Malaviya National Institute of Technology, Jaipur. He did his PhD from IIT Patna and MTech from NIT Durgapur. So he has been teaching here along with me in MNIT Jaipur for the last 12 years. And he has held various roles in the institute as well. So I'll request him to introduce Ms. Nivedita Dey.
So hello everyone. I hope you are enjoying the course so far. And before we jump into the module, let us introduce our first speaker of this module, Ms. Nivedita Dey. Nivedita Dey. She has been a researcher in quantum computing and quantum information science and affiliated with University of Calcutta, and she presently works as a at QRD Labs in Kolkata. And she's also involved in different industry in R&D and has connected with Kolkata also. And she's presently working as a PricewaterhouseCoopers in Noida. So I think she has published a number of research articles, and she has been a regular speaker in these courses. And we have seen her earlier also in different courses in the earlier Q202 also and other courses also. So without further delay, let us welcome her to start the first module in this particular course. Welcome, ma'am.
Good afternoon, sir.
Yes, good afternoon. Please, yeah, you can start.
Okay, sure. Let me share the screen. Good afternoon, everyone. And so those who are like new to this particular security session, so what I will be planning is I will try to put it for both of them, like who is the whoever has joined for this particular session, or if he or she has also completed the QT00 and 01 together. So today's class will be because already Dr. Pillai has given a certain introduction of what you can expect for this particular season, but primarily this will be all about learning all the functional components of quantum physics as well as quantum mechanics, mostly from the computing angle. Okay, just to create that base so that you can further continue with the algorithms or the advanced parts of the quantum ones as well. So likewise only I will be like dividing the it per day wise, that in that order, in that essence I will be planning the sessions so that it is maximum understandable and the primary goal of this particular course will be maximally achieved or accomplished. So on that note, we will be starting. So today's class will be kind of an introduction. We will set up the kind of plane or the base so that we can continue from tomorrow onwards, or more on the technical things. Directly we can jump into the preliminary mathematics and all everything that is required to understand all the postulates. So that is what is our planning. So first of all, and pardon my voice, I have like suffering from viral, so I'm trying to be as loud as possible. So I hope it's clear. Otherwise, just let me know. I'll try to add in some other way as well. So first is why there is so much of a hype on these emerging technology, just like GenAI and all. So of course, the reason being, direct reason is because of a lot of stakeholder engagement and their kind of vision as was, or like how they're like watching this technology, or like watching this technology to evolve in recent years as well as in the some very immediate years to come. So what their vision is, there are several sectors where it is anticipated that quantum technology, computing, algorithm, then optimization, quantum machine learning, all these fields are going to do wonders. Of course, the credit goes to the like hardware developers or whoever is working on the developing the components on the physics level or on the electronics level, as well as to the developers who are working on the algorithm side, who are developing novel niche algorithms. So we will be talking about all these things. So first of all, there are a certain kind of notion that quantum has the potential to disrupt the financial services sector profoundly in the longer term. You can see it as it is a like a some kind of theory by FCA, Financial Conduct Authority research agenda. Okay, then 40% of the large companies are planning to create initiatives around quantum by end of this current year, 2025. And being a part of a big four in PwC, which is primarily a consulting firm, so they are also into a few of the emerging technologies where they are primarily putting maximum of their fund or their focus on quantum as well as generative AI. So these two are right now in so much of a hype because of the money that is being put into the technology or the development. As well as you can see that in 2019 also there was a huge kind of a commitment made by our government of India on development of like quantum technology altogether. It was kind of a 8,000 crore something investment commitment was there. So from that onwards, and because of these all these initiatives and the NQM and all, so academically also there is a lot of that vacancy, or say that kind of a ground that has been created for quantum. And also in European Union, or say in a lot of countries around world, that need is like exponentially increasing, the need for resources for quantum. So there is definitely a market. At least we have understood that. Okay. Now, the thing is that whenever there is a market, there is a lot of some other. Let us start with some of the real use cases. Let us start to understand it. Why this kind of thing is required? Or should we be applying it to anywhere? Wherever we want to apply it on, or is there any specific thing? How to analyze the importance? For that, I just have taken one example. You can see that. Say first example is you are working on some protein folding problem. So in pharma, protein folding is a very like complex problem, or it's a very kind of a profound problem that you can see. Where what is it? Like you are given the millions of the protein configurations, and your target is that what will be the best protein folding structure that you should be working or considering further for the development of the drugs. This is the kind of thing. Now, why this is very challenging? Because just taking this path, like checking all the millions of configurations, then taking one, then that will be a true positive. Because mostly these are false negative, like false positive and true negative cases. But the probability to come up with the best one is so time consuming that if it fails, then it is not actually in real time. Then you will be like far beyond the what you can expect and what you are actually having as a pharma company. So another thing is, say for example, you are delivering a car or some navigation system has to deal with a lot of scenarios. Now scenarios can be, say, different weather conditions you have to also simulate. Then you have to consider all the traffic conditions. Then if there is a new road, then in real time the construction status of that particular road is another challenge. Traffic signals and all, you have to manage that as well. So whenever there is a multi-parameter kind of thing, and that too you have to manage in real time, so there is a lot of data. And if you do not do properly, like if you do not take all the data together, then maybe your decisions making system or that kind of optimization outcome may not be optimal. And if it is not optimal, then consider the real scenario where there are costs associated with like traversing each and every route. Now, if you are not left with the optimal route as an outcome, then it will automatically just keep on increase your cost of the overall target that you want to achieve. So likewise in logistics, in supply chain, in pharma, this is the optimization part. Also in cryptography and like cybersecurity, even in blockchain, in a lot of places, there are real scenarios where quantum is either a threat or it can actually do wonders. Okay, so next is here what we have got is there is a real need that we all need to take care of, because there is an alternative, that is quantum. This is all we have understood. Now the next question is why the existing classical setup is a problem. So we will be putting a little deep dive into the current situation and try to understand its problems, because so far everything was very good. Now we will be understanding that is there literally any pitfall in classical way of computation that quantum can actually handle in a better way, right? So the first one is, just consider the example for the protein folding one or the like car navigation system. So what is the problem? That is, there are a few problems that actually, that explosion in the state space, if we do that, that will increase exponentially, because it will incorporate trillions of possible solutions to put into your consideration. So every single path you have to explore. So in very easy word, wherever you have a state space tree or graph and you want to actually do a brute force, so for that kind of problems where each and every configuration will actually yield to like an exponential increase in your state space, okay, that is called combinatorial explosion. And on a few problems, like I just have said, say you have 4 parameters to work on. So likewise, you will be designing your basically test set, right? That there are 4 combinations. So just considering the null one, just removing that one, it will be 2 to the power 4 minus 1. That is a combination. Say A, B, C, D, 4 parameters you have. So either it can be only the singleton sets, that is a 4C1, or it can be taking 2 at a time. So AB, AC, AD, BC, BD, and CD. That is a 4C2, or it can be like all 3 of them together. So it's 4C3, like ABC or ACD or BCD or like what ABD. Likewise, or it can be taking all of the like 4 parameters together, all of them together, which can be only one, 4C4. Now, if just you imagine if you have one more variable, and that is a mandatory variable to be taken under consideration, or a parameter to be taken under consideration, then that is A, B, C, D, E. So of course you can understand it's basically 31 number of combinations. Or in easy words, it's a 2 to the power of n number of combinations. So likewise, there are certain problems where there is no option to eliminate the parameters, and there will be possibility of a combinatorial explosion. Combinatorial as the like literal meaning of combinatorial, that logic. Okay, and why explosion? Now you know. Okay, next one is a non-deterministic problem. There is a small story here which I want to share, that our human brain, you know how it works. Basically, say I have asked you that please you pick up a random number between 1 to 50. Then you will be telling me maybe 29. Then if I ask you next time, you will be telling me 7. Then maybe in the next time, you will be telling me 10. So is there any particular logic? Until and unless you have your, say, friend's birthday or your birthday, or you are some way biased with a few numbers. If I remove that kind of biasness, which is very less probabilistic, because you will be not giving or having that much of a time to think. So very randomly you have to just tell. So our human brain works in a very non-deterministic way. Meaning, at a particular point, it can actually have all the 50 numbers. Then any of the one number you will be directly telling. So similarly, another technology is there. That is the like our DNA, deoxyribonucleic acid, the DNA, like the genes that we have. They are also the nitrogen bases. They are very random and there is no logic behind that. Like adenine and thymine, and then guanine and cytosine. These are the nitrogen bases. They are connected. So you do not know that after a point whether adenine thymine pair will come up or guanine cytosine or cytosine guanine pair will come up. So which nitrogen base to come up in the next genomic sequence, that you do not know. And similarly, there was other one technology which works in the similar way. That is the photon particles in nature, because it has the light as well as the wave property. Now you do not know that if you measure, those who have attended the Q200 and 01, you know, we had a concept of a quantum random number generator. We have seen that at a particular point, a quantum particle, if it is measured, it can give any of the random sequence. It can either give a 0 or it can give a 1, or it can give, say, 10 zeros at a time, no 1, then maybe 20 ones or 1010, any random sequence it can give it to you. Now, the DNA, the genomic structure, and the quantum, both of them work in the non-deterministic model of computation. And mostly, a lot of real-world problems, they actually need this kind of a very strong computing mechanism. That is why we have built a computer called AI, artificial intelligence or something. We have built the technology. So computers, or the classical computers that we have, they cannot work non-deterministically. Even the ChatGPT or all these kind of generative AI or the LLM or everything. So it has to be very hard coded. Yes, there are semantics, there are some advanced logic, there are a lot of grammars associated with that logic, but it will be deterministic. That is, from a particular point, on having a particular input, you can exactly visit one state, not multiple one. So that mapping is very much of a one-on-one basis. Okay? It is not like a one-to-many basis. It is not like that. So there has to be certain kind of a metric, or say kind of ranking system, where out of say 5 words you have, which word will come in that as the next word, that is very much already pre-decided. Why? Because the classical computers, the transistor logic that we have, the NPPN diodes, all those things that we have, the CMOS logic, complementary metal oxide semiconductor logic that we have, everything works in the deterministic model. It has a fixed rule to work on. But mostly a lot of such problems are there which require the non-deterministic way of computation, which is not supported by our any of the classical computing logic or algorithm. Right? Next one is the parallelism limitations, which means that the way we encode a logic, encode an algorithm in classical, they do not naturally support parallelism. Meaning, if you have to support parallelism, you have to separately deploy some parallel CPUs into your setup. So the computing device itself, or the computing unit, processing unit, you have to double or triple if you need to double or triple the speed of your computation. Okay, so do not get confused with the parallel computing and the parallelism. Parallelism means we simultaneous, that is in the same time frame, how many tasks you can deploy with the help of only single one processing unit. So if you increase the processing unit number, say 2 you have, then you are making it 3. Then maybe a subtasks you are actually allocating to different processing units, parallel processing units. Then that is parallelism, but that is a pseudo parallelism because you are deploying more devices to take care of that. But naturally, even our best supercomputers that we have, though parallel computation is possible, but parallelism cannot be achieved. And because of all these 3 things, the way classical computing works, that failed. And these are all 3 are the same reason for which a new computing model has evolved, which is quantum. Right? So that means so far, whatever algorithm that we have seen, we have worked on, we have implemented, no matter in which field, everything is classical. So all of them are deterministic. None of them can support combinatorial explosion, for which we have actually thought of bringing those optimization or say approximate amortized algorithms and all those things, advanced things, where we try to like mimic the optimal solution if it is not the exact solution. But finding the exact solution is not possible because our classical ones don't support it. And also there is a practical limitation in offering the parallelism by the classical devices. Okay. Next is the Turing machine model. So you all know the Turing machine model, it is a very fast kind of an abstract, say abstract computing logic, you can say. So there is no such any physical thing, but it's just a mathematical model of predicting that how a local computer they work. So as proposed by Alan Turing in 1936, it's a mathematical model of computation that defines the working principles behind classical computing. So it is an abstract device. So it has a certain things. What are the things? It is using a finite set of states. Okay. States means intermediate state of a particular classical say variable or say classical say computation unit that I can say. So one state. Likewise, there are a finite set of states. So in automata theory, whenever we will be discussing more on the complexity classes and all, so we will be talking all details about all the Chomsky classification and the Turing ones as well. But this is a very fundamental one. If we have to talk a little, say in a computing tone or in a tone of mathematics, then it has a certain kind of a read-write symbol, and there is a kind of an infinite tape, where the simple thing is in discrete time step, either from a point we can move to left, then do a certain operation, maybe read or write, whatever we want to, then we will or maybe update, then we will come back to the or make another move, right? And similarly, that is we will change our state. Similarly, we can go to back to the right, then do a certain operation on having some input, we will be going to right, do certain operation, then again we'll come back to another state or that initial state, or remain within that state. And likewise, whatever we are reading or whatever is the output of the Turing machine model, after that, through some like acceptance criteria or through some empty machine logic, we will be ultimately deciding that whether a language that will be accepted by the computing device or not. So this was a fundamental principle behind the Turing machine model. And it is the foundation of all modern classical computers. And it also shows that any computation problem solvable by an algorithm can be performed using a system that follows the principles of Turing machine. Again, there are a lot of such things: halting problem, undecidability. We will be talking, or recursive language, recursively enumerable language. We will be talking in details for the complexity ones. Okay. Then how does it work? I already have said it, how a Turing machine works. So it has a tape, it has a read-write head, a finite control unit where we have that or the delta or the transition function, set of the transition functions. And with all these three things, it works. And so there are like key properties are deterministic, we said, because we just have mentioned that every device that we have, every computer that we see around us, they are only built on deterministic logic. If it is not quantum, step-by-step execution, definitely, and with a one-on-one mapping that is defined in the transition function through delta. So they follow a fixed logical sequence, and of course it's binary. So limitations are time complexity. Some problems require exponential time to solve. We have seen that because of the combinatorial explosion and all. Space complexity. Some large-scale problems require unrealistic amounts of memory. And we know right now in the big data thing and all, there are like space is a real challenge to like incorporate into the computing. Then last two principles are a little again different than what we discussed. It is the irreversibility and the energy loss. So every step that we do in classical, they are by default irreversible in nature. Now, irreversibility in anything means that whatever was your initial information, then after a certain operation, after a certain, say, black box, you have done something. That can be anything. After that, you got some output. Now, if from that output, anyway, you cannot trace back what was your original input, then that is the irreversibility. And in each of these operations, there will be a loss of energy associated. Okay. But, so what does it mean? Like loss of energy means some information is also lost in the system. So the information retention capacity is very less in your case of classical computation. If you remember, we were talking a little about the quantum gates in QT00 and 01 as well. And we have seen there that except the NOT gate, which is an inverter one, all the classical gates like AND, OR, XOR, XNOR, even NAND, NOR, all these gates that you have, they all of them are irreversible logic gates. Okay. Of course, on the contrary, in quantum, we have seen that every operation, if you again like redo it, it will be the same one. So actually that means an arbitrary quantum state, they can be somehow again restored. So you can actually retain some of the all the quantum states during evolution. It's not cloning, it's just restoring that original quantum state. Okay. And the fourth one is the inability of classical system to model the quantum system. Because a few things actually needs to be simulated in a quantum setup only, or some of the natural setup. So from now onwards, whenever I will be referring natural means I'm referring quantum, because nature itself is follows all the quantum physics and quantum mechanics postulates. But that nature, again, that is very something that is itself is in the quantum world or quantum, say, kind of world. Yes, that is the best word. Because it is in such a level where the macro physics, the classical physics principles, like they cannot be adopted to explain those kind of natural phenomena that is happening quantumly, which we do not have any access about. So if you remember, there were a certain algorithm type we discussed in the last one where it was a simulation algorithms, and I mentioned that there are specific problems where we want to simulate the properties of nature, how it works quantumly. For those things, we actually cannot model them in bits or the way the classical things are built on. We cannot do that. Neither this algebra can define that, nor these classical hardware or algorithm can define that. Next, a few examples of what we discussed. So time complexity. So some problems require exponential time to solve, and mostly the problems are the category of NP-hard problems. They are basically something that actually incorporate exponential time. In a line, I want to just explain what is an NP-hard problem. So NP-hard problems are very hard to be solved, or say in a little technically, it is, say you have a class of students. Okay, you have a class of students, and there is a topper in computer science. Right? Now, if a student from say another institute who is also a computer science topper enters into your class and challenges you that what hackathon problem you can solve, I can solve any one of them. Or if I cannot solve, then none of your like students can solve it. Say this is this kind of a challenging thing. He is actually claiming. He is a outsider, okay? And he's claiming into your computer science class that I can do the best. What I can solve, none of your students can solve. So that external student from another institute will be called then NP-hard problems or NP-hard problem. Then who is the NP1? Or your students in your computer science department, they are NP. Meaning, if a problem is as hard as any of the problems that reside within the NP class or NP set, then that problem, outsider problem, is basically called an NP-hard problems. There are mathematical definitions of that. We will look into that things later. But as of now, if anyone is new with this thing, so just understand it in this way, that NP-hard problems are generally mathematically very hard problems. So it's mostly kind of an optimization problem, not the decision problems. Okay. For example, just say the traveling salesman problem, where we actually find the optimal tour. There are several cities which a salesman needs to travel. Okay. And all that cost will be summed up. They will be actually have to pay all the taxes, say, or all the cost, have to bear all the cost. Then after that, with what optimal route the salesman will actually come back to the original point with a certain consideration that vertices cannot be covered more than once. But edges, if you want, you can skip. You cannot as well, but if you want, you can skip. But you have to come back to the original node. And third condition is that all the nodes have to be definitely visited. You cannot skip any of the vertex, but you can skip the edges. But vertices cannot be repeated except the starting vertex. So it's kind of like A, C, B, D, A. So only the A and A, first day and last day, they have to be same. Otherwise, meanwhile, you cannot repeat it. So that is a TSP problem. Now, we will be seeing again that how exponentially that cost grows if we actually, and in terms of time as well, if we just increase one city, because the complexity itself is in order of n square into 2 to the power n. So that means with n equals to 10 if you give, so you'll be getting 10 square 100 into 1024, which is a 102400. But if you just increase it with say n equals to say 15, then it will be 15 square, which is 2 to 5 into 2 to the power 15, which is I guess 32768 or something. So say 30,000. 30,000 into your say even 200. That is an exponential increase with just increasing the 5 number of cities. And you can imagine that in real world, definitely there will not be 5 or 6 cities to consider, because they are in thousands or they are at least in hundreds of cities in real time. So there are problems which by default will bring into picture the combinatorial explosion, that thing. Okay. Another one is the factorization of large number. where I've seen the classical algorithm like the RSA decryption. So they actually required sub-exponential to exponential, something like that time. Whereas quantum computers via shorts can actually solve it in polynomial time because of the shorts quantum Fourier transformation. Right? Another one is the space complexity, just like the protein folding simulations we are talking about. So modeling the behavior of a complex protein itself, that requires storing an astronomical number of molecular states. Why, these are just simple, like in a hydrocarbon state, right? So it's a CNHN or CNH, say CXHY, where just the carbon configurations or their bonds, and there are a lot of like ortho, meta, para positions. So if you change that one, if you change the angle, if you change the molecule, even their like inherent structure, then that will keep on increasing the number of molecules that you can actually consider for the best drug. So this is very difficult in terms of space as well, because you have to actually store as well all those kind of molecular configurations. Similarly, there for the high dimensional data processing tasks, it is the same thing. Okay. For mostly for the systems where there are large scale machine learning data set, due to right now, right, for the LLM thing, training and all. So that is also a challenge that we have. So if there is any smart encoding thing that you can come up with quantum, and at least you can have that to encode the data, then maybe you can save some of the space as well, because of part of it will be storing in quantum and a part of it you will be storing in classical. But definitely, if you do that encoding logic, you also have to come up with some decoding logic as well. Okay, just to give you that notion that, okay, these are the like cases, these are the areas where there are real challenges, where we actually try to bring the quantum into picture. Right? Third one is this one, the irreversibility. Classical computing processes are inherently irreversible, and they lead to the energy dissipation in form of heat. So this is a Landauer's principle, where erasing a single bit of information actually, remember, single bit of information, that is one bit, 0 or 1, dissipates at least k into t into log n log 2 amount of energy, where k is the Boltzmann constant and t is the temperature. So that is the like energy dissipation amount per bit. So that is why we can see that anytime, every time, there is a lot of heat dissipation. So basically the hardwares are working also in that particular way. And cooling cost for supercomputers, that is also because of this massive heating, you need some massive cooling architecture or infrastructure. So it is very unsustainable for the future computing needs. If the amount of information that is so huge, so humongous, so that is also some challenge. So that is why we are currently shifting to the more of the energy efficient computing, green computing, and all those things. Right? So any quantum thing itself by default is this one, considering that you actually bring it to that like temperature, pressure, whatever is required, you actually have that kind of things, a tick mark of all those things during you are setting up a quantum computer. But once you are doing that during a single, say, pipelined fashion, I'm talking about, whenever you are putting one particular instruction in a quantum computer, it will actually dissipate very less amount of heat. Okay. And then the inability, because atomic and subatomic level things cannot be explained using your classical bits. Okay, because you cannot do that. So here also the challenge is in the observation level, the classical physics and the quantum physics. And also the last point you can see, those who attended the Q200 and 01, you know that the quantum cryptography It was such a huge challenge there. We talked a lot about that. So quantum cryptography and security, because the classical encryption models are also something which do not naturally capture the quantum randomness. So the seed and the initialization vector that we talked about. So both the things are lacking that inherent randomness. So whenever you are using them as a cryptographic key or seed in your, say, public key or private key algorithm, it will remain vulnerable to the quantum attacks, for which we are actually aiming for, heading towards the quantum resistant or quantum safe cryptography. So this was another phenomena. So we all talked about it. So this was superposition. So far we have seen what are the pitfall in our classical thing, how we can or why we need to shift towards the quantum, or maybe not quantum, or some advanced form of computing. So the challenge or the fundamental, say, pitfalls we have so far understood. So this creates a base that we need to go for some different versions of computing. Now is the ground, and we also have seen that quantum offers a non-determinism. Now is the ground for us to understand that why quantum is so powerful, why there is so much of hype around quantum in a technical sense. So the first one is its property to be in superposition. So superposition is a property, or say power, which is the most fundamental or say most promising feature that quantum offers. So everywhere we actually, whenever we'll be seeing some exponential speed up or advantage or anything, we actually bring into picture the essence of superposition, where it is the power of being in multiple states simultaneously. What do I mean by simultaneously? Means the real essence of parallelism. So whenever we are encoding anything in that quantum setup, so you will actually be able to parse, or you actually able to proceed with, or say implement, right, or say traverse anything you are assuming that way in all that encodings simultaneously. Now what you will be encoding? You can encode a variable, for example, say ant colony optimization, right, where basically what you can encode, say you are just devising a quantum ant colony optimization. So what you can encode? Maybe you can encode the trails or the pheromone trails that are used by the ants, or maybe you can use some of the like cumulative graph weight, or maybe the food sources, you are just ranking them in some for something, the evaporation, any logic. So that is what I'm trying to say, is that is up to you. But the thing is that once you encode them, then you can actually proceed with calculating with all those encodings together, if you are able to successfully encode it or use the principles of superposition. Okay, and remember, this is the principle. Now how to encode it, it is in your hand. But the phenomena is, in classical computing we use a binary bits or bit, binary digit or bit. So it can either be 0 or it is 1 at a given point of time. For example, I just give this example every time. Say you have 5 fingers in your hand. I ask you that what is the number that you can represent at a time. Consider your finger down is off or 0 and finger up is 1. If I ask, say, this question to say 5 students, so maybe the first one will give me that, okay, I can encode 0 1 1 0 1. Second will say I will be encoding all 0. Third will be saying I will be encoding 1 1 0 0 0. Right? So at a time, only one number you are able to encode if you have 5 fingers in your hand. This is clear because your each finger can be either a down or a up. But let me consider that don't have the classical fingers kind of thing. Rather, my all fingers are quantum bits or qubits. What is qubit? It is basically the quantum analog of classical bit. So I have that quantum bit or qubit, where it's like that every finger is both up and down or somewhere in the middle kind of state. So until and unless I measure it, it is basically each of the fingers are actually holding together the 0 and the 1, both of them together. So if I have only 5 fingers or 5 qubits, then how many total quantum states? Quantum states I can encode? I can encode 0 or 1 into 0 or 1 into 0 or 1 into 0 or 1 into 0 or 1. That is 2 into 2 into 2 into 2 into 2, which is equals to 2 to the power of 5. That is 32 possibilities together simultaneously I can hold. This is simply superposition, nothing else. So in classical, where it was with 5 fingers, we were able to encode only one configuration. In quantum, with similar 5 quantum fingers or quantum bits, we are actually encoding all 32 combinations together. So this is superposition. It's a on and a off together. So you can see that what is superposition. So here qubits store and process information as 1s or 0, as well as a combination of both of them at the same time. That is a superposed state. Right? We just have seen the example. Whereas in classical, there is no superposition, there is certainty, where the binary bits store and process information as 1s and 0s only. So it's one specific value, right? And just see the at the very bottom, for example thing. So say all stock variables, all of their configurations, like what are the parameters and all, everything, very strategically, you have encoded in a quantum computer using qubits, using superposition, all the quantum gates, everything, all the building blocks, you have put it like safely and you have given it to him, to the computer. Then what is this ROI? So quantum can actually calculate all the possible stock returns simultaneously and can give you the ROI for all of them. Or what is the best ROI? What is the stock combination to choose? You can actually feed everything together in a quantum. Whereas in a classical, if you have to do that, so individually, all the stock variables, parameters, configurations for a particular stock you will be calculating. Then maybe in an array or a structure or array of structures, whatever you want to deploy, you will be deploying. Then individually you will be calculating their return or ROI. Then another logic or the minimum maximum something you have to deploy in order to get that which is the best ROI or best pattern or say best bucket to consider. Right? So these are the real use cases. Okay, I just want to pause a little here and want to ask. Let me just see the questions. Voice is breaking. Okay, is there any doubt? So far, you have any doubt? Till now, whatever we have discussed? I think, okay. I think for the ones who are having some doubt with the voice, you can actually try to rejoin.
Yeah, I don't think there is any problem with the voice. Voice is very clear. So participants kindly recheck your own system. As of now, there is no problem. Yeah. Any questions? Ma'am is giving a pause here. So if you have, yeah, so far so good. Yes, ma'am. I think we can move further. If you need, you take a break of 1 or 2 minutes. That's fine. Yeah.
No, that's not required. Okay, thank you.
Right. Sure. Okay.
Yes. So one power you have seen, that is a superposition. So just also remember that tomorrow onwards, we will be mostly talking about a little bit of more of the mathematics things for all the Dirac notation and all, whatever is required, the basics of quantum physics and like all the Hermitian matrix and all, everything. So if you want to do a recap of those things of the basic preliminary linear algebra or the vector space, you can definitely have that kind of preparation. Otherwise, we will be doing it. So there will be a lot of such things. So basically, in the very first lectures, we will be just creating the base. That is it. Okay. So the next one is your entanglement, where it is a kind of a special connection between entanglement directly in terms of computing or in terms of speed up. There is no such advantage that quantum offers, but mostly the flavor of entanglement is visible in communication and cryptography, or say teleportation, all these things. So entanglement is basically kind of a concept where we believe that two quantum particles, even if they are separated by a space-like distance, still they share a certain kind of a mystery when they are together or if they are entangled. Now that mystery technically means it can either be a positive or an anti correlation. So somehow the relationship between them or the behavior exhibited between the particles, they are somehow interlinked or interconnected. So a similar kind of a proportionate or a inversely proportionate behavior will be seen. Meaning, for example, in teleportation, we have seen that. So one of the entangled pair is basically given to Alice and one has given to Bob. So they are a part of the entangled pair. So it is a single pair with say 2 qubits, where 1 qubit we are allocating to one party and another qubit we are allocating to another party, assuming that both the parties are separated by some distance. Definitely, in reality, it is not a space-like distance, but it is just our assumption that even if they are separated by a space-like distance, it can be done. You can actually distribute the entanglement of the entangled pairs or those two qubits to two different parts of the quantum communication channel. Right? For example, just an example is when you roll your dice and get a 6, your friend's dice automatically lands on a 6. Say, okay. So this is just an example. So this kind of concept of an instantaneousness and the correlation is referred by a entangle. Now, as I said, it is very powerful because in quantum communication, in quantum key distribution, teleportation, super dense coding, in all these things, there is a huge application of this thing. And this is doable. In real time, this is actually doable. We just have the constraint of a particular that distance, that how far actually can be maybe put. Okay, that is the only challenge that we have. Okay, so classical is basically independence, meaning you cannot really create something like that where two classical bits will be behaving in that same way instantaneously, right? You cannot create that. So it's always independent. And see, remember, flag is a logic. So don't think like there is a if condition. So if will create that kind of a dependency. This is not about that. Entanglement is not about that. Entanglement is say somehow you have written a function where whenever there is addition here, subtraction will be taking place, or at another addition will be taking place at another end. Something like that is the meaning of dependency or entanglement in quantum. So another one is quantum interference. It's kind of a dancing of the probability waves. Okay, so interference is the like theory of where you are on a, say, pond. Whenever you watch a pond or any basically water body, we'll be seeing there are a lot of waves, and often like few waves actually cut each other or they form a bigger wave. So a lot of such things happen. So if they align, they create a bigger wave, and this is constructive interference. So whenever they are interfering, is creating something constructive, something bigger, it is called constructive interference. And if somehow two waves due to interference cancel out each other, they disappear, that is the destructive interference. And how it is related to the probability and all, okay, so I had a 30%, some story I actually told you during the QT00 and 01. So in this session, QT02, we will look a lot into the interference and how the probabilities will be adjusted, and if possible on Qiskit as well, we will try to visualize a few of those things, that how the probability density curve or the distribution functions, they actually change due to the interference change. As of now, just remember, if something is aligned, it will be a constructive one. If something is not in alignment or cancelling each other, then that will be a destructive interference. And why this is very useful? Because quantum computers, so whenever say I have the 32 possibilities, 32 encodings with my fingers, I have done that. Now say there is a particular or say certain properties that I have incorporated as a logic in my quantum algorithm, which from the 32 states 0 0 0 0 0 0 to 1 1 1 1 1, from the 32 states will actually yield as the best one. Say for example, I have just now want those solutions which have alternate number of 0 or 1, alternating pattern, say 0 1 0 1 0 or say 1 0 1 0 1. So only 2 will be the correct options. None of the rest of the options will be correct. So out of these 32 states, how actually I can come up to the only 2 states? That process is known as interference. Why? Because we have used this concept known as the destructive interference to delete the 30 unused or not important states, so that we also can consequently increase the probability of the 2 correct states as our answers. Okay, so that probability correction, or mainly for that purpose, so that our convergence is easier, we actually rely on the interference things. Okay. Okay. Okay, this is all. We already have done these things. So another one is the no cloning theorem, which is a quantum copying limitation. So this is the basically the principle where we believe that a quantum information, if it is an arbitrary information, that cannot be copied or that cannot be cloned, or in easy word, there cannot be any machine that I can, or any device that I can actually build which will be able to clone any arbitrary quantum state, considering that I do not have any knowledge of the preparation, meaning what was the exact configuration of the quantum bits that I have chosen. Say I have taken a quantum register of 5 qubits. I have a 5 qubit quantum register, meaning a memory, quantum memory of 5 qubits. And if I do not have any information about that, what was the bias, how much it's like a maybe what is the exact state of the superposition that I am taking when it was in a 5 qubit state. So that information, if I do not have, That is the preparation contextuality. The context about how it was prepared, if that information is not available with me, then I cannot create or build such machine, which is kind of a Xerox machine, which is able to clone the original quantum state that we have. And where it is very useful, it is very much useful in order to just get the presence of some eavesdropper or intruder in quantum cryptography or communication. Say I am an intruder. There is a valid like security intensive application is there, and there is a communication. Some military informations are being shared. Some DRDO project is there. I am the intruder. Now what if I got that intel? I'm able to clone it, and also the Ministry of Defense is unable to get that. So what they will assume? They will be assuming that their information is safe because they are unable to detect me. So the real challenge is not about not letting me get that original information. But what more threatening here is if I remain not detected to the defense team or to the ministry. So for these particular situations, so when I am able to actually remain under the shadow, if I am able to clone whatever quantum information that they are using to share, using to actually share the information, if I am able to get that, because it is quantum, then immediately that information will be lost. But what if I am able to, or I have a machine to again clone the information or just restore the state? If I am able to do that, then I will be undetected to them. So the man in the middle attack, that possibility will totally or has totally been evaporated when this quantum actually came to offer the no clone. So quantum supports no cloning theory, right? So the duplication of a quantum data or a quantum state, if it is arbitrary, that is not possible. And quantum decoherence is basically, as I've said, the decoherence is the enemy of a quantum communication. So every quantum systems are extremely fragile, and any interaction with environment, if it affects or get affected by the heat, light, air molecules, pressure, even the qubit interactions, which is known as coupling. Okay. Also the time, because after a certain time, the quantum systems will automatically evaporate or start degrading or degenerating. So a lot of such things can disturb the quantum state, making them behave classically instead of a quantum mechanically. So if you lose the quantum property, what will happen? It will actually behave like a classical property only. Then what will happen? Like no flaws, but actually the flavors of quantum superposition, entanglement, and all those speed up concepts, or the reason for which we are here, that will actually be broken. Because even a smallest push or an external noise will make it fall over. So that is why what our aim is, see, you can see the features like superposition, entanglement, interference, no cloning, and decoherence. So what will be our aim? Our aim is to selectively pick up the features as per the application requirement. This is the first point. Second is we have to understand a few things from today's class. That is, if we need some speed up, how we can speed it up using some smart encoding, how we can do the smart encoding using quantum superposition. So all sort of speed up, advantage, supremacy, everything is associated with the term or the quantum mechanical phenomena known as superposition. Clear? Second one is entanglement. Again, when to use it? Whenever there is a situation where there is communication challenges, or you actually want to get the flavor of the quantum bits together, okay, want them to behave instantaneously or in the similar fashion under the same roof, then we'll be using entanglement, where it is used mostly for teleportation, super dense coding, and quantum communication, quantum key distribution, a little bit of quantum cryptography and all those things. Done. Where you will be using the third property, which is interference, mostly in all the quantum algorithms, wherever during measurement or just before measurement, you need to curate what you want to measure. So this is up to you, how you want to play with the interference in order to get the desired output. Quantum is natural. We are not natural. So we have to extract from the natural body of the quantum computing or the quantum computer, we have to extract information in our classical way. But before doing that, out of the superposed state, we need to do some little bit of cut paste. So for that purpose, we will be using interference. So it mostly deals with the probability. So increasing it or decreasing it, meaning increasing some quantum state or decreasing some quantum state, right? So it is mostly used in quantum, designing the quantum algorithms. Fourth one is the no cloning theorem. Where to use it? You don't have to use it, just you have to remember it, that there is no opportunity you can get to clone some quantum state. So you don't have to try to clone it because it is not possible. So it's a theorem. Okay. Fourth one, last one is the decoherence. Where to use it? Nowhere to use it. This is a challenge. This is an enemy. So we want to actually fight with this thing. We have to very smartly deploy some error correction technique, use some advanced routing strategies, transpile it in a better sense, apply a lot of such compiler level optimization techniques. Whatever you want to do, you have to apply everything of them so that the decoherence, you can minimize it as maximum as possible. So these are all the features. So how to use it? For that, we have to know that what they do. So today we covered what they do, so that you understand the utility of how we are going to utilize the features depending on the requirement. I think we are done with the time, so I can pause here. So tomorrow I will be covering this part first, then I will start with the further topics, mostly for the mathematics. So one thing is, you can actually have some quick walkthrough of the linear algebra concepts or vector space, tensor product, some of the matrices and all these things. You can do that. What is the minimum time the system is in coherence? That depends, sir. That depends. So basically, of course, it is in terms of some nanoseconds only, but it's also constantly evolving. I think it's very, very much hardware dependent, how much they are offering, and everything can undergo into the decoherence. Not only the qubits, the quantum gate, the quantum bits, everything, and all the quantum gates, all the quantum bits, ancilla, everything can undergo whenever it is under that quantum setup. Okay. Any question you have? How we will be understanding the system lost coherence between qubits? Definitely, whatever output you're supposed to get, you will not be getting that. So it will be in terms of that erroneous output. In teleportation, cloning not happen? No, Gauri, it is not cloning. In teleportation, basically what we do is we reconstruct it, but reconstructing a particular quantum state without sharing any knowledge with each other. And if you have done it, or even if it is there in QT02, I have to check, then I will be again talking about it, the teleportation. So it is basically not cloning any particular quantum state. If you know, see, when it is cloning, if I have something and I want to clone it, then I should be ending up with two outputs, right? One is the original one and the second one is the cloned one. But in teleportation, it is basically I have something, now you have something. So this is not cloning. It's kind of some like transferring what I have. I have just transferred some money to you, say for example. But it is not cloning. Cloning is when I also have money, you also have money. That is called cloning. I hope it is now clear. Okay, let me go. One asked a question on, let me just check, cross-validation, okay. I will be, whenever I will be discussing about that communication or whoever will be discussed about communication, you can get that real flavor as well. Otherwise in QT00 and QT01, I covered that one, the teleportation and super dense. If meanwhile, if you want, you can actually go through that. You can actually see that how that entangled Bell pair, there are a lot of things. Or maybe in QT02 also, we will get into that. But mostly entanglement is used in quantum communication rather than in computing. Yes, classically requires more memory. Yes. This means 2 to the power, okay, 256 qubit classically requires more memory. Yes, it means 256 is 2 to the power 256. So that is astronomically very huge. So that is what they try to refer, that much of an information you cannot actually store classically. Okay. NP heart problems, I will be detailed discussion we will be having on the time complexity, P, NP, reversible, then recursive, non-recursive, decidable, halting problem of Turing machine. Even I will be discussing about the Chomsky classification, the TSP, why it is an NP heart problem. So we will see the entire state space of that particular thing during the complexity. Just hold on your patience for a few more days. Cross-validation of some results, that you can use some classical simulator as well, just to validate the output, and for the checking the source, whether it is generated from some quantum source or not, like source validation. That is some lab level thing. That is something that is only tested by some labs, or some through some real photon detectors and all. But for result verification, for numeric result verification, you can actually cross check it with the classical devices as well. Okay. Of course, we can store qubits. We can store qubits. That is all the quantum hardware they are doing. We actually are able to store qubits. The technology is not the like CMOS one and all. That is different, but we can store qubit. I will share the slides. Thank you. No, it's not exactly. Okay, one encoding and one. I think just hold on for tomorrow. Maybe tomorrow I will talk about it. It's not 100 to 2. You cannot even do that. So there is a limitations. There is some logarithm relationship that how much or how exponential performance you can get. Of course, there is a mathematical limit to that, but the encoding, if you are able to do that, it can be exponential. Again, it can be. This is the max limit. That now that depends on you and your exact problems. For interference, basically there are a lot of combination of gates, Satish. So if you check the Grover one, they are also like ultimately we are doing some sort of like from the inversion about the mean and all those operators. We are actually incorporating interference, but there is no such direct gate for that. Okay, that this is the gate for interference, not like that. Like we have something for superposition, which is Hadamard. We don't have such direct gate like this gate is for the interference. We don't have any directly. Okay. Okay. Is it okay now? Yes, yes. Books I will be sharing in the slides itself. Just check the last slide. There I have put some links of some books. Okay, you can get the names from there.
Yeah, we will also share some list of books. If you go to the syllabus of the quantum minor curriculum, which is there in AICTE website, you can see a lot of textbooks for every course. QT02 also some textbooks are referred, but of course for Madam's lecture, Madam will also share her. Right. Yeah. If there are no questions, we can conclude. Yeah, thank you, Nivedita ma'am, for the wonderful lecture. And I think, yeah, for those who have some questions on the program, you can now ask. So we will continue the lecture tomorrow. Nivedita ma'am will start the lecture at 3 o'clock. We'll have the lecture from 3 to 5. After that, Sunday will be a break. Again on Monday, we'll continue the lectures with Nivedita ma'am. Nivedita ma'am will take first 5 days. We will be taking the lectures. Then again, after some time, we will again have her coming back, right? So the whole quantum mechanics portion will be addressed by Nivedita ma'am. She's working with PricewaterhouseCoopers as a consultant, but she's doing a PhD in A.K. Chowdhury School of IT in University of Kolkata. Professor Amlan Chakravarti is our supervisor, is a well-known figure in entire West Bengal. So we are fortunate, and you will be happy to know that she's been teaching quantum computing since 2021. We have conducted first time we have conducted in 2021, where Jaikumar Vaitishankar was a student. So you can understand. But anyway, she's also young compared to all of us, but she's very passionate about teaching and also about quantum. Any comments by anybody, sir?
Thank you so much, sir.
Yeah, thank you, ma'am. Thank you, ma'am. Sir, you would like to add any comments? Vice Chairman, sir.
Yeah, it's a wonderful lecture by Nivedita. I could listen whole lecture without going out also. A lot of information, and she has covered very well the basics of quantum technologies, the difference between classical and quantum and other things. So this is a good beginning, and I'm very happy that she will be taking for 5 days. Very wonderful talks, and I'm very happy. Thank you for this whole session. Okay, so we'll meet maybe tomorrow. Okay.
Yes, sir. Thank you so much for your encouragement. Thank you, sir. Thank you.
Thank you, sir.
Thank you.
Right.
Thank you,
ma'am. Participants, please wait for those who are in QT01. If you have any doubts, any clarifications required. QT02 also, if you have any doubts and clarifications required, you can please let me know. Anil sir is there from AP State Council for Higher Education. Dr. Anil Kumar, please, you can make the announcement. Nivedita ma'am,
Yes,
if you're busy, you can excuse yourself. Thank you, ma'am.
Yeah, good evening.
Yes, sir. Please go ahead.
I thank Professor Madam for her wonderful session. And sorry for the delay due to as today's inaugural session is there, and many delegates are participating from APSA side. Maybe your time, we consumed your time, madam. Extremely sorry for that. From tomorrow onwards, the whole session will be yours. I request the participants, particularly who didn't get the certification in spite of completion of 3 quizzes, there are some queries. So it is a mandatory to enhance the quality and the sanctity of the course. We have asked the amenity to consider at least a minimum of 70% of attendance. Earlier, we asked for 80% of attendance, but anyway, now it is reduced to 70%. And our Emmanuel Subhakar sir is very kind enough, and now he want to reduce further till 50% of attendance. So I request all the participants who have due to receive these certificates are requested to at least watch your videos through login in your Canvas. Now I request the organizers to once again, sir, because still there are some confusion in login of their Canvas accounts, and they are also failed to attempt some quizzes. Now I think all the quizzes are open again for those who have not attended. And many participants didn't get because they didn't put up at least 70% of their attendance during this live sessions. Now there is a facility that you can again log in, watch all the videos. Is to sensitize more and more faculty members as the students are also getting connected with this. Sir, there is a proposal, sir, Emmanuel Subhakar, sir. Can we join our students also for this certificate course? Can we?
Yes, sir. Yes, only thing is they must not be disturbing the proceedings by asking unrelated questions. If they can join, but they must not disturb the lectures. Actually, they must listen, and because if they ask unrelated questions, then it will be difficult otherwise. So third year and final year students who are doing quantum courses, definitely we can encourage.
Otherwise, we can ask the institutions who are there.
Right.
Allowed to watch this live sessions through their conference halls.
Sir, live session, YouTube is open, sir. All of them can watch on YouTube anytime.
I think this is better. Can you give the certificate also for those people?
Sir, FDP, because it's a faculty development program.
No, this is my concern actually.
Right.
Because our government is very serious about training these students also.
Right, sir.
So anyway, you are offering the credits for these certificates. We can train some of them. This will be useful also. Okay, later we can plan, sir. Now
Right.
the session is open for the faculty members who have some doubts and queries regarding their certifications. Why they didn't get that certificate, what happened to their quiz program or their attendance program, any issue is there, please get clarified.
Yeah.
There are 275 members are there. I think those who got the certificate in the first PUT, you can leave. The rest of the people who are not able to receive the certificates, please stay back.
Yeah, let me clarify. First question that where do we find the quiz? You must be a new participant. So quiz will be available once you get access to Canvas. We are sharing Canvas. So Canvas student Canvas, once we give the login, you will see the files. Then under the files, you will see quizzes. And once you click on quiz, you can see quiz 1, quiz 2 like that. As in when we open the quiz. So in a week's time, we will open quiz 1. Then you can see all the questions, multiple choice questions you can answer. Each quiz will be of 30 minutes, but you'll have to answer only 20 questions. It will be multiple choice. More answers may be there. More questions, more options may be correct. More than one option may be correct. So you can try to do that. So that is one thing. And secondly, go ahead. Secondly, some of you are asking questions about QT01. Yeah, I already took all the quiz of